Hi everybody, I would like to welcome you to my presentation about unlocking the potential of IoT. But first, let's start with an introduction about our company. So, Miromico was founded in 2002 as a spin-off of IoT Zurich. The company focused mainly on chip design in the beginning, but with the growing interest in IoT devices, the embedded systems department also grew rapidly. Here you can see a little timeline of the products that we did in the last 20 years. We did a lot with asset tracking, smart metering, but probably one of the most important products of our company is our module, which I will get back to later. We also did a lot of products in collaboration with different companies. When we look back at the last 20 years, we of course also ask the question, where will we be in 10 years, and how can we contribute to sustainability? Just like in politics, Miromico has also a target plan for 2030. Our first mission is to develop smart devices that can help bring a sustainable future. We can do that with smart metering, monitoring, smart actuators, and stuff like that to help save energy and resources. The second vision is to save resources during the whole product life cycle and also during the development of our products. We do that by using our own module. With our module, we have way less overhead during the development of a product, but we also have the big advantage that the customer can switch out the module even after the development of a product is finished. Like that, we prevent that thousands of devices get thrown away just because a new chipset or a new technology arises. A second plan to save resources is by developing easily maintainable devices. That means, for example, putting replaceable batteries in it. But more importantly, we try to prolong the lifetime of our devices. We do that with energy harvesting, and in extreme cases, we can even go batteryless and don't use batteries at all. Third vision or goal of ours is to always stay at the edge or leading edge of technology. Already in the last years, we have seen that the power consumption of microcontrollers and sensors is going down rapidly, while the computational power is going up. Also, there has been a lot of development with connectivity technologies. We try to improve our devices continually with those advancements in technologies and provide a lower power consumption or smarter devices. To stay at the leading edge of the technology, we also try to collaborate with universities all around the world. A good example how smart sensors can improve sustainability is a recent project of ours that we did in Switzerland in supermarkets. By putting temperature sensors in fridges and freezers in supermarkets, we were able to monitor the temperature continuously. Until now, the temperatures in those fridges and freezers were set manually to a fixed value, and they had to be checked once a day manually by an employee of the supermarket. Because of our continuous monitoring, we were able to prove that most fridges and freezers were set to a way too low temperature, and that we could set all the devices to a temperature about 2 or 3 degrees Celsius higher. By doing that, we would save a lot of resources and also money. 2 or 3 degrees Celsius doesn't sound like a lot, but if we sum that up with every fridge and every freezer in all supermarkets in Switzerland, we would save money that could power a small village for a whole year. Let's get back to our superstar, the module. So over here, we have an overview of all the modules that Miromico offers. All of these modules offer MCU for the computational power and a radio chip for the connectivity. If we start on the left, we see that in the beginning we mainly focused on LoRaWAN with the SX1272 and the SX1261 chip, but in the recent years we also added Wi-Fi, Bluetooth and IoT to our portfolio. With the LR1110 module, we even offer a module that has geolocalization capabilities. All of these modules share the same footprint, the so-called Miromico standard module footprint. Like that, it makes it very easy to swap out the modules in devices, and we have also no overhead during the development phase of products. Of course, we also support this modular approach in software. So also our software can be compiled to almost all of those modules, and swapping out the module is as easy as changing a compiler flag. The counterpart to our modules, of course, we also offer. Those are the gateways. Miromico offers an indoor and an outdoor LoRaWAN gateway that supports all LoRaWAN regions in the world, and even supports the 2.4 gigahertz version, which is allowed all over the world and therefore ideally suited for global tracking applications. To stay true to our modular approach, we also offer the gateway functionality as a mini PCIe Express card. It can be put into custom devices or even swapped out on our gateways when a new chipset or a new technology arrives. To give you an example of this modularity, we take the Miro Insight. The Miro Insight is a sensor that measures temperature, humidity, and air quality. By default, this device gets shipped out with a LoRaWAN module that supports the European region. Because it has the Miromico standard module footprint, we can easily swap out the module to all the mentioned modules over on the right, and therefore support technologies like LoRaWAN 2.4 gigahertz, IoT, Wi-Fi, Matter and WirePass, or Bluetooth. If we take the modifications a step further, we can also try to increase the battery lifetime or the lifetime of this device. As a proof of concept, we added energy harvesting to the Miro Insight device. We added a solar cell on the case, an energy harvesting chip inside, and a supercapacitor. Because of the low power consumption of our device and the sensors, we were even able to remove the batteries completely. Like that, the device has a theoretical lifetime of unlimited lifetime, and compares easily to our device with a battery that has a lifetime of around 10 years. To make all our sensors smart and connect them to a useful use case, we have to use a radio technology. Like already mentioned, the LP1 is a very important technology for us, and we use the LP1 is very important for us because it has the advantages of a long range and a low power consumption. The only downside of these technologies is the low data rate, but that's usually not a problem for our IoT devices. Over here, we can find the LP1 devices with some examples like LoRaWAN, NB-IoT, MyIoT, and Sigfox. In the recent years, there has also been a trend to use satellite technologies in embedded systems. Like that, we are able to offer wider coverage, even in remote areas. Some examples of satellite technologies that can be used in embedded devices are LoRaWAN from space or NB-IoT from space. To stay on the edge of technology, we of course always use the newest chipsets and technologies. We have here a little overview of chips that we used in the recent projects, like for example, hardware accelerators for machine learning, new radio technology chips, and for example, energy harvesting chips with very high efficiency. To stay in contact with universities, we also use the Pulp RISC-V chip, which is developed at IoT Zurich. As already mentioned, we try to use energy harvesting in our devices. A good example for energy harvesting or where it can be used is an excavator. Excavator has a really big motor and creates a lot of vibration. With a small device that is attached to the motor casing, we can harvest enough energy to charge a battery or charge a supercapacitor, and therefore prolong the lifetime of the device. Other sources for thermal energy harvesting could be thermal energy or solar energy. Like I said, in the most extreme cases, we are even able to remove the batteries completely and just use a supercapacitor as a storage device. To show you a little bit where we came from and where we are heading to in the future, I took an example of a GPS tracker. As we see in the past, GPS trackers were very bulky, had a high power consumption, and were inaccurate. Now what we can offer today, that's a GPS tracker with a very small form factor, about 2 times the size of a 2-franc coin, a battery lifetime of up to 2 months, accuracy below 5 meters, and we even offer indoor and outdoor tracking. If we go to the future or look into the future, of course, we always want to make things smaller, better, and last longer. So the idea would be to have a tiny form factor like showed in the picture. Ideally, unlimited lifetime with energy harvesting, and with the recent development of geolocalization technologies, we aim for an accuracy below 1 meter. The last example before I finish my presentation is also how to use AI on microcontrollers. So we did a collaboration with the University of Applied Sciences in Zurich, where the goal was to count the cars in a parking lot without placing individual sensors on every parking spot. With normal computers or servers, this wouldn't be a hard task, but we tried to do it in an embedded device with a low power consumption. With the help of the MUX78002 chip from Analog Devices, we were able to train and run the neural networks on an embedded device that is running on 3 lithium-ion cells for up to 4 years, while continuously monitoring and reporting the number of parking spots. As we can see, also the max rating of those chips differ greatly. So on the embedded device, we have around 0.5 watts, and a normal graphics card or a computer uses around 125 watts. Okay, that was my presentation. I hope I could give you an insight about the visions that we have at Miromico and how we can contribute to a sustainable future.